like I said, piece of paper out here. Get into what we're going to do today. The major things we're going to discuss, all right, are going to be domain, range, okay, and end behavior of functions. Okay, we're going to talk more generally today just about domain, range, and end behavior of kind of generic any kind of function. Okay, as we move along in this class, our units are going to be kind of divided up by kinds of functions. So like, for example, within this unit, okay, after we kind of get the general idea of what's a function and like the ways to describe, you know, any kind of function, we'll look specifically at absolute value functions, how to do transformations with those, how to describe their domain and range, and like all the different characteristics that come with absolute value functions, right? Then later we'll look at like quadratics, that's like x squared. We'll look at cubics, x cubed. We'll look at stuff like square root functions too, square root of x, okay? Each unit will kind of be, you know, organized by a specific kind of function that we kind of look more deeply or closely at, okay? So this one we're just kind of getting a, you know, a general kind of broad range here. Okay. Before we start talking about domain and range and behavior, though, we have to learn or talk about how we're going to describe them, and that is with an interval. Okay. An interval is simply a part of a number line, okay, without any breaks. Okay. It's like a section or a chunk of the number line without any breaks. Okay? There are two kinds of intervals that we're going to be looking at. There are finite, okay, and there is infinite. And don't ask me why I pronounce one finite and the other infinite. That's what my understanding is how they're supposed to be pronounced. So change it up when you have the IN in front. Okay? So I think we kind of have an idea about infinite, right? It means the interval keeps going. So we'll say it's unbounded. There's no boundary on one or at one or both ends. Okay? Unbounded. That means you either go forever in one direction or you can go forever in two directions. Okay? Again, this is talking about a number line, right? And then finite, well, that just means then that it's got two endpoints. Handwriting. And also, please, if you can't read my handwriting or something like that, please, you know, say so, and I'll, you know, tell you what it is. My apologies. These markers don't always write the best. Anyway, it has two endpoints. And those endpoints may or may not be included, too, in the interval. Okay? You might include the endpoint, you might not include the endpoint, right? Okay. So let's take a look at some examples. So, for example, here it is in words. All right. So here are some examples. I'll just put a little EX, for example, there. Okay. We'll say all real numbers from A to B, including A and B. Okay? So here's an example of an interval in words. Okay? It's part of a number line. It's all the numbers between the numbers A and B, whatever they happen to be. And they also, the interval is going to include A and B. Okay? Is this a type of a finite or infinite interval? What do you guys say? Finite or infinite interval here? Finite? Why? Yeah, it's got two endpoints, right? It doesn't say, like, keeps going, right? We start at A, we stop at B. It's finite. Okay? Okay, finite. And then there's different ways to describe intervals, right? So obviously there's words, okay? There's inequalities and there's set notation. We're not going to worry about those. The big one we're going to worry about is interval notation. Okay, so we're just going to use interval notation as our primary way of describing these things. You may have used inequalities before. You may have used, well, probably not set notation. But anyway. Okay, so interval notation, we're going to use A as our starting point, B as our stopping point. Okay, and then we include A and B. Do you remember what kind of grouping symbols we use if we include A and we include B in our interval there? What type of grouping symbols do we use? Yes, the square brackets, exactly right. The square brackets like that. Okay, because we're including A, including B. Okay. If we wanted to exclude A or if we wanted to exclude B, what kind of grouping symbols would we use? What's that? Parentheses, that's right. Okay, parentheses. All right, so let's take a look at a few more here in words. Let's say all real numbers greater than A. All real numbers greater than A. All real numbers greater than A. Okay. All real numbers greater than A. Finite or infinite? What's that? Finite or infinite? All real numbers greater than A. Infinite! Okay. Infinite. Yeah, we've got a starting point, A. All right? We're talking about all the numbers greater than A. How many numbers are greater than A? An infinite number of numbers. So this is an infinite interval here. Okay? So for this interval, we're talking about all real numbers greater than A. So we're going to start with A, comma, and then what's the ending? What's kind of like the second number of our interval going to be here? What number will it be? Infinity, right? Because they're going to infinity like Buzz Lightyear, all right? Should we include infinity? Is infinity ever included in an interval? No. Why? Because we can't ever get there. Okay, you can't ever get to infinity, right? The idea of infinity is it keeps on going, right? And so the idea of being able to get to infinity means that you could go a little bit further then, right? So that means we're never going to include infinity. Never include infinity. Should we include A in this interval? Does it say all our numbers greater than or equal to A? It does not. So again, if in words we're trying to describe all the numbers greater than A but not equal to A, should we include or exclude A? Exclude it, exclude it, right? We do not want it. It's not counted. A is not greater than A. We need other numbers, so all numbers from A to infinity. Okay. Your smaller number in your interval should always be on the left. Your bigger number should always be on the right. Okay, so we kind of had to assume here that A was smaller, B was bigger. Okay, but there it is. All right, here's one for y'all to try. Okay, so we'll try this one. All real numbers less than or equal to B. Okay, so take like 30 seconds there. Okay, go ahead and try that. All real numbers less than or equal to B. Again, I want to know whether it's infinite or finite, so tell me if it's infinite or finite. And then give me the interval over here in interval notation. Describe it in interval notation. That's the primary one we're going to be using. All right. Let's go to... Ooh. Okay. Let's see here. Make sure I got the right person first. Should I use that here? Womp womp. Let's go to... Patrick. What do you say, Patrick? What would you get here for your answer? Infinite. What gave it away here that it was infinite?
It said less than.
Uh-huh.
And there was only
Okay, yeah. All real numbers less than or equal to b there. Yep. Mm-hmm. Perfect. Yep, it's infinite. Very good. And then were you able to come up with the interval notation then? This one's a little bit trickier, so if you had some trouble, I mean, I'll help you out here too, but...
Is it
Be on the right side. Yes. Be on the right side. What number should go on the left-hand side? What? Negative infinity. Because we want all real numbers to the left of less than b, so all the numbers to the less than b, you want to go negative infinity to b. We're going less than b, so that means it's going to be negative infinity we go to there. Yes. And you want to have that negative infinity first, though, and then b second. So very good identifying the b goes second there. Okay. We never include infinity. And then should we or should we not include b here? In this case, Patrick, what do you say? Should we include it or not? Equal to, so yeah, include it. We do include it. Okay. We do equal to b, that's okay. Okay. Cool, cool, cool. Of course, you got the words, right? That's pretty easy to describe the interval notation. We should also be able to describe intervals, if we see a picture of it too, okay? So let me just do a couple examples here, and then I'll have you guys try some. So for example, again, we'll just write the interval given in interval notation. Okay. Write the interval given in interval notation. So here we go. Here's a picture. Number 1. Now I'm going to be a little bit lazy with my number lines here. I hope you'll forgive me. You guys probably don't want to have to write more than you need to anyway, right? So just help you out here. Okay. So now we're going to draw an actual number line. And I'm going to show a graph just like that. It's an interval, right? You can see we're talking about a part of the number line, right? A section of the number line without any breaks, right? There's no breaks in that part. It's all one part right there. No breaks. A part with no breaks. Okay. Peyton, is this a finite or infinite interval? Finite, right. Yeah, we got a starting point, we got a stopping point. Okay, starting point, stopping point. Finite, very good. Okay. Justice, back to you again. How would we describe this interval? Can you do it here for us? What would be the interval? Where do we start? Where do we stop? -3, comma, till what? 2. Do we include the -3? Yeah, what about the graph gives away that we do include the -3 there? Yeah, it's filled in, right? And then number 2, the 2, do we include that or not? Do we include the 2? Yeah. Yep, no, again, filled in point there. Okay, it's filled in circle, we include it, right? And all the stuff in between gets included too. Okay. All right, we'll do one more here together, and then I'll let you guys try one here on your own. Let's do this one. And again, I'm just being a little bit lazy here. You can put more numbers on your number line if you really want, but I'm not. Let's do this. Okay. So there's our interval. Okay. Think about what's going to be an interval notation here. Let's go to Jason. What do you say, Jason? First of all, is it finite or infinite here, Jason?
Infinite.
Infinite. How can you tell?
Because there's no like stopping point.
Yeah. It's just going to keep going to the left there. That's right. Okay. Very good. So this, and I guess I could write that finite here, infinite here. Okay. So again, for our interval here, what is the leftmost point going to be according to our picture? What's the leftmost point going to be? What do you say, Jason?
Negative infinity.
Yeah, negative infinity. That's right. Okay, it's going to go all the way there towards negative infinity. Right, this is like negative infinity down here. That's positive infinity up there. Okay, and then what's the right endpoint of our interval there, Jason?
Comma 2.
Comma 2. Okay, parentheses. Very good for both. Right, parentheses for both. Yeah, we don't include the 2. Open circle. Right, we don't include the negative infinity because you never include infinity. Never include infinity. Can't get there. Okay. All right, 2 seconds. Not 2 seconds, but here's 2 more for you to try. Okay, so you guys try these. Number 3, number 4. Okay. I'm just going to squeeze them in here real quick, like this. What are we going to do? Negative 3. All right, well, that's silly. I'll do... Okay, there's number 3, interval notation, please. And then number 4, let's do this one. Whew, no lose paper. Bless you. So again, writing those intervals, think about where we're starting, where we're stopping. Right? Where we start, where we stop. Okay. Good. 30 more seconds. Start, stop, start, stop. Okay, that was 30 seconds. Let's take a look. Number 3, let's go to Kyler. Kyler, what do you say here is our interval? What is the interval here? Where does it start? Where does it stop? -1, and it goes till 7, okay? Do we include the -1 or exclude it? Excluded. Okay, yeah, open circle, and so we're going to draw parentheses there. Yep. And then this one's a filled in dot, so we're going to include it, square bracket like that. Okay? Very good. And that one, of course, finite. Finite. All right, let's go to Geo. Geo, you got an answer here for number 4?
It's infinite.
Infinite, very good. Okay, I'll put a little I, N, F there, and I'll put an F, I, N for that one, okay? What is the starting point of this interval?
0.
0. And it goes to what? Infinity. That's right. Do we include the 0 or not?
Nope, they're both parentheses.
Okay, parenthesis here. Be careful, that 0 is filled in. See, filled in dots, we're going to include it. So square bracket there for the 0. But infinity, yeah, is parenthesis. Okay. Question on 1, 2, 3, 4. Easy peasy. Okay. All right, so now let's throw in our actual. So this is what we're going to be using to describe domain and range, okay? But I wanted to make sure we were, first of all, good with intervals before we get into the actual talking about domain and range here. All right, so you guys talked about domain and range before, I know, okay? But I want to just refresh our memories about it just because sometimes it's easy to forget, okay? The domain, okay? What does the domain describe? Anyone remember? What does the domain describe about a function? We normally talk about it with domain and range, right? Normally they're paired up like peanut butter and jelly, right? Okay, domain describes something, and then range describes the other something kind of thing, something like that. So, yeah, which one is it, Mike? Do you remember? Domain describes. Okay, so it's, yeah, side to side, x values, exactly right. Okay, so the domain, you can think of it, describes all possible inputs. If you want to think about a function as having an input and an output, right? Or like the inputs like the independent variable, stuff like that. All possible inputs, I'll put that in quotes, okay? Or x values of the function. Describes all possible inputs or x values of the function. And so then the range, the jelly to the domain's peanut butter, right? What will that describe? All the possible y values. You got it. Exactly right. Describes all the possible y values. So I'm going to put all possible outputs or y values of the function. Okay. Our primary focus, though, for today is being able to look at a graph and describe its domain and its range. So let's take a look here at an example, and we will describe the domain / range of each. Okay, and we'll do 2. I'm going to try and make these easy since we're hand drawing them too, so I won't try and go too crazy there on us. All right, just to make it kind of easy. Okay, so there's our function. Okay. So, we want to describe the domain here. That is, what are all the x values that our function is going to hit here? Okay. What does it look like? What does it look like? And I know it's hard to say here, but I think we can, yeah, we'll be okay with this. What does it look like the farthest left our curve is going to go here? How far left do you think we're going to go here? To what? I didn't put any numbers down, right? Guess I could. Let's see here. 1, 2, 3, 4. Okay, you guys get the idea. We're counting by ones here. 1, 2, 3, 4.
Yeah, go to the bathroom.
Let's wait for this one, and then I'll let you go. So, what's the farthest left that we go here? Okay. values. The domain describes all the possible x values, or all the possible inputs. So we want to see here, right? I mean, do we have an x value of -1? Yeah, looks like we're going to have an x value of -1, right? Looks like we have an x value of 0, 1. Of course, all the numbers between, because we're connected here. But what's the farthest left this curve is going to go? -3? -2? CJ? Yeah, so in a case like this, okay, with the arrows, yes, we're obviously, it looks like we're definitely going up, but as we go up, we're going to continue to move ever so slightly more and more to the left, okay? We are going to keep moving left here. And so in other words, we will eventually, if you continue to draw the graph, we'll eventually hit every single x value down here. So the lowest x value we're going to have, -infinity. So our domain, okay, is going to start at -infinity, and then what's the farthest right we're going to go here? Yeah, positive infinity, yeah. Okay. -infinity to infinity. And so that's it. That's our domain. Easy peasy. Okay. So again, domain, you're thinking left to right, right? Left to right. Range, because we're doing y values, we're thinking of bottom to top. Okay, bottom to top. Domain, left to right. What's the farthest left to the farthest right? Range, what's the bottom to the top? Bottom to top. Okay? Is our range going to be -infinity to infinity too? Same thing? Why not? Oh, what's the stopping point here?
0.
Okay, yeah. Our lowest point, we don't go any lower than 0, right? We get to 0 right there. So we're going to say our lowest, bottommost point there, y value again, is 0. And what's our highest point? What's our highest point? Infinity. Positive infinity. Okay? We never get to infinity, so we'll round parenthesis there. Do we get to 0? Yes, include it. We do get to 0. Okay? We do get to 0. All right. All right, who was it that said they had to go to the bathroom? You want to go? All right. Number 2. Okay, number 2. Take a look at one more graph here, and then I'll have you guys try one on your own. All right. So this is quadratic, right? The first one there, that's quadratic, right? Like x squared or something like that. We'll look at those more in depth, I think, in a later unit. This graph right here is going to be an exponential function. Okay, and I'll, again, just do a rough sketch here. Let's see, we're going through 1. Okay, something like that. And again, so here's our curve. Okay, again, we're going to describe the domain and the range. Okay, so remember, domain, left, right. Domain is left, right. Okay, so, oh, AJ's number's up and he's out. Twice. All right, let's go to Tatum. Can you describe the domain for us here? What's the farthest left that looks like our graph is going to go? Yeah, -infinity. Yeah, it's going to keep going, -infinity, 2, and then what's the farthest right that looks like our graph is going to go? So it looks like we might kind of like curve up here, maybe have like an asymptote or something like that. This one, it's going to keep going here. So if it does keep going, what's going to go to? Infinity. Yeah. Yep, infinity here. Okay, and I like that you're looking for that stuff. We do have that stuff occur every once in a while. Sorry about that. there's our domain. And then, of course, Tatum, with that, do we include infinity ever? No. So parentheses all around. Okay, very good. All right, next one, a little bit trickier here. What does it look like the lowest? Not Tatum, thank you. Well, we'll go to someone else here. What does it look like we should maybe use here? Let's go to Sam. What's it look like the lowest y value is going to be here? If you had to guess. Does it go down to negative infinity? No. It looks like not, right? What does it maybe look like the lowest y value we're going to approach is here? 0? Yeah, 0. Okay. What's the highest y value we're going to approach here, it looks like?
Or 1.
Okay, well, we hit 1 for sure, right? Because there's that. But then it keeps going up. Okay. Now, does it look like our graph is ever going to actually get to 0? Doesn't. It's going to approach it. So we're going to put a parenthesis around that. Okay. And of course, we can never get to infinity. So again, parenthesis around that. Okay. Very good. Questions on any of that so far? Ready to try one on your own? Sure. All right. Here we go. I'll zoom out a little bit so you guys can refer back to these. So here's one for y'all to try on your own. Okay. Then we have end behavior, but we'll just use these 3 graphs for the end behavior too, and then we'll move on. Okay. So I'll do my best to sketch these. So there's our function right there. I'll call that function g of x. Okay. So again, give me the domain and the range of that function right there. Okay. Go ahead and give me the domain and the range of that function right there. Domain and range of that function right there. Again, yeah, sketch it out for yourself if you need to. Remember, domain, left and right. What's it look like the farthest left we're going to go? What does it look like the farthest right is we're going to go? And the range, what's the lowest, what's the bottommost point we're going to get to, and what's the highest point we're going to get to there? Domain, leftmost x, rightmost x. Okay, range, bottom x, bottom y to top y.
Yes.
Bottom to top for range. Good. One more minute. Let me try to figure this out. One more minute. Figure this out. Okay, so we're going to do end behavior after this. We'll use these same graphs for that end behaviors. So domain and range. Domain and range. Domain, left to right. Range, bottom to top. Done. Okay. Volunteers for domain. Volunteers. Anyone? Brave souls. Yes, CJ, go for it. negative infinity, positive infinity. Perfect. Yep, parentheses are on both. You got it. Good job. Okay. How about someone else for the range? Someone else for the range, please. Volunteers. Volunteers for the range. Go ahead. Let's go to Patrick. Negative infinity to 0. Okay, of course, never include the infinity. And then should we or should we not include the 0? Include the 0. That's right. There we go. Okay, perfect. So the last thing, like I said, I wanted to talk about here was the end behavior. I'm just going to squeeze that right into this little quadrant right here. So end behavior, not a very creative name because it describes the behavior at the ends of your function. Both what happens as you go really, really far to the left and what happens as you go really, really far to the right. Thank you. Okay. So how do we describe that? All right. So for the, let me see here. We're going to describe end behavior in two ways. Okay. The starting way is going to be as x approaches, and then if we want to describe going really, really far to the right, if we want to describe going really far to the right, what will x be approaching if we go really far to the right? What value? Positive infinity. Yeah, positive infinity. So we're going to say for end behavior, as x approaches infinity, we'll say f of x approaches. Well, then we have some options. F of x could approach positive infinity, f of x could approach negative infinity, or f of x could also approach a number too. Okay? And so we're going to fill in the blank. That's going to be the blank. That's the question we're going to be answering. Okay? Because for end behavior, we're always going to describe what happens as we go really, really far to the right, and we're also always going to describe what happens as we go really far to the left. I think I might have gotten those backwards for us, but okay. So, and then so of course, if we describe what's happening as x goes far to the right, that's x approaching positive infinity. If we want to describe what happens as we go really, really far to the left, that'll be x approaching what? Negative infinity, right? Okay, and again, our purpose here will be to fill in the blank. What's happening to the function? Is the function going up forever and ever and ever? Is the function going down forever and ever and ever? Or is the function approaching a number forever and ever and ever? Okay. So let me show you what I mean by that. So that is end behavior. That's how we're going to be describing it. Okay. And this way. And this is the work that we do. We just need to fill in this work right here. Okay. So let's go back to number 1 here. I'm going to scoot it back up here to number 1. I'll put this part in red. So we'll say here, as x approaches infinity, okay, so in this particular one, as we go really, really far to the right, what's happening to the value of our function here? What happens to the value of the function? What's it approaching? As we go really far to the right on my function here, as I keep going further and further right, what's happening to the y values here? They're increasing, and they're going to go up to infinity as well. So, as we go far to the right, f of x also will be going up, increasing. Okay? So f of x will approach infinity. As x approaches negative infinity, now as we go really far to the left, as we go further and further to the left on our function, what's the value of the function going to approach? Negative infinity or positive infinity? Because it's going up still, right? It's going up, so it's positive infinity, actually. It's positive infinity, yep. So f of x approaches positive infinity because we're going up still. Yes, we're moving to the left, but we're going up still. Okay? So maybe like, this is easy. Either I'm going to have to say positive infinity or negative infinity, and that's my answer. Well, let's take a look at number 2. Let's take a look at number 2. Okay? Number 2, again, the setup's always going to be the same. As x approaches infinity, f of x is going to approach something. As x approaches negative infinity, f of x is going to approach something as well. You'll always have the same setup for these end behaviors because you want to describe the ends. What happens as you go far to the right? What happens as you go far to the left? Those are the ends, right? Left end, right end. Okay. So, in this example, as x approaches infinity, what does f of x approach? As we go farther and farther to the right on our function, what is the function, what is the y value? What are the y values approaching? Infinity again. Yeah, infinity. It's going to keep going up, right? It's going to keep going up. without bound. Up to infinity. Now, as we go further and further to the left, is it going to go to positive infinity? Does the function go to positive infinity as we go further and further left? Does it go to negative infinity? As you go further left here along the curve, what value are we approaching? What y value are we approaching here? 0. The answer is 0. Okay? 0. Okay? Sam kind of helped us out here with this range idea. That kind of like clued us in, okay, as we're going further to the left here, we see that the range is approaching 0. Okay? Now, granted, the range won't always, match up here like that, but it helps kind of analyze that, okay? You get closer and closer to 0 there, right? And so we're approaching 0. Okay? So in this case, we're not approaching 0. Okay? And then for this last one, and we'll stop here. For this last one, again, as x approaches infinity, as x approaches negative infinity, well, I should put g here, I guess, because we're talking about function g now. If you put f of x, I probably won't count it wrong, but do understand we are talking about g is the function's name here, not f. As we go further and further to the right, what's g of x approach? What's the y value's approach? Negative infinity. As we go further and further to the left, what do the y values approach? Negative infinity as well. Okay. So, there you go. All right. Questions on any of that? All right. So at this point, you would have had, on a normal class day, you would have had a good 20 minutes to get started on your homework, but because it's a 2-hour delay today, you didn't get the full amount of time. My apologies. Okay. But ordinarily, I do really try and give you time.